we'll start the talk. Again, fingerprinting web applications by variations and ping implementations by Dominique Bongard. Thank you.
Thank you. Thanks everyone for showing up. I'm Dominique. I'm going to talk about how you can use variation in PNG libraries to fingerprint what's going on web servers. And it's going to be a 25-minute talk, so I will have to skip on some details. I hope it will still be clear. So to start, a few details about me. I'm from Switzerland. I run a small IT security company. My main interest is in reverse engineering, and especially in embedded devices. You might have seen some stuff I've done on Wi-Fi, and I'm also a mobile application developer. So what is this talk about? I will first introduce the concept of schizophrenic files, which you might already know about, and I will explain why it is interesting to fingerprint image libraries. Then I will explain quickly the PNG image file format and MNG and JNGs, which are variations of it. Then we'll show how we can differentiate quite a few common PNG libraries. Then I will show how to apply that to web servers. And I will show some practical results on some big websites. And I will present small tools that can automate these things. So what are schizophrenic files? Schizophrenic file is a concept that has been introduced by Angel Albertini. I don't know if you heard of him. He often writes in the proof of concept or get the fuck out easing. There's number 5 will be released at DEF CON, by the way. And these are files that use ambiguities in a file format so that they will render differently depending on which program you use to view them. So as an example, here it's one PNG file. It's one single PNG file that renders differently in the Windows image viewer or in a viewer that is called iMagine. So it's the same file. You open it in one program or the other, you get a cat or a tiger. So how does that work? You have the image, basically, the cat uses the 4 lower bits of each byte, so the low nibble of each byte for its data, and the tiger uses the high nibble, the 4 high bits of the image. And then you have 2 different palettes. One that will show it's a paletted image, right? 256 colors. And one of the palettes will show the tiger, and one of the palettes will show the cat. And it repeats for the low nibble or the high nibble. And then I make a PNG image, if you can see here, that has 2 palette chunks. One with the first palette, and one with the second palette. So normally the specification says that you should only have 1 palette. But the specification says also that if an image has a problem, you should do best effort to still try to display it. So what happens is that some programs will say, hey, that's an invalid file. Some program will display it with the first palette, and others will display it with the second palette. And this program here is TweakPNG, which is a very good program if you want to tweak PNG image files. It's very useful. So basically, all my tests are done with this sort of images that tweak the standard or the specification in some way so that various libraries will interpret them differently. So why would we want to fingerprint image libraries? So we'll take what they say directly on the OWASP website. Website server fingerprinting is a critical task for the penetration tester. Knowing the version and type of a running web server allows testers to determine known vulnerabilities and the appropriate exploits to use during testing. So that's very high level. If we go a bit more technical, fingerprinting gives you information about the framework and language of the web server. It can give you information about system libraries. For example, PNG uses zlib for compression, and also libpng, for example, or not. And you might also uncover attacks through native libraries. That means you might have an application in Java, but then it might decode the images in C, which means you might use buffer overflow, which you cannot do in Java. And usually it's pretty hard to hide this kind of fingerprints. It's pretty easy to remove the 404 images on a website, to change the headers of the web server, this kind of stuff. But hiding what the image library does can be quite difficult. So one example from the past, not about ping, but about TIFF, an exploit in the buffer overflow in the TIFF library was at the base of one of the iPhone jailbreaks. So that shows that image libraries can be quite a risk in your applications. So now I will detail a bit more the ping format. So it always starts with this 8-byte signature. That's mandatory. But then the rest is just a bunch of chunks in basically TLB format, not exactly. So each chunk has a length, a type, which is 4 letters, and then the data followed by a CRC. You can also have chunks that have a length of 0 and no data. So I don't know if you can read this slide, but you have chunks that are critical and which must be in every image. And some are allowed to be several times, and others must be one single time. So an image must always start with the header chunk, which is IHDR, which must be first and only once. This one contains like the width, the length, and stuff. If it's a paletted image, you must have one palette before the hidden chunks. Like you saw in my cat tiger image, I put 2. And then the IDAT chunks, you can have several. That's the one that contains image data, and they must follow each other. And the image must end with the IN chunk always, which is a null length chunk. But you can do a lot of funny tricks, like have an IN chunk that is not at the end, or which has data in it, because it doesn't really matter, in fact. But some implementation will say, hey, that's invalid, and some will say, I don't care. And then you can have a lot of other chunks that are called ancillary. That's basically optional chunks, and you can put commentaries, like you put dates in them, time of creation. Like a library is capable to read an image without knowing about those chunks. And then you also have variation in the ping format, which are called Ming and JNG. Ming files are basically the GIF animes of ping, that's animated files. And JNG is the lossy version of PNG, that's basically JPEG in PNG. And they have a starting signature that is really different from PNG, but you might be able to put chunks that belong in one format in the other and see what happens. And one interesting point is that if you take an MNG or JNG file and you call it .png, ImageMagick will be very happy to decode it. And so it's a very good way to find out if a web server is using ImageMagick to decode its files. So which library did I try? I tried with Golang, PHP 5 with GD, the image library, OpenJDK 7. For Python, I tried with PyPing and Python image library. I tried C#, the mono version, and the official Microsoft version. And you can, by the image library, you can very easily make the difference which one is mono and which one is .NET, because I don't use the same image library at all. I also tried with PNG.js in Node.js, Chunky Ping in Ruby, ImageMagick, the Dart image library, IMG in Erlang, LoadPNG, which is in C. That's a nice C library for ping, and Juicy Pixel in Haskell. So what I did is I made a lot of images, like the one you can see, which are all invalid or strange in some way. I will I have put them on GitHub, and they're probably also on the Black Hat site if you want them. And first result I got is that that's the Ubuntu file manager. You can see that the one up right, it's actually empty, it doesn't have data. And you can see it shows basically empty memory of stuff. There's a memory corruption somewhere here, because there's absolutely nothing in this image. So the data comes from somewhere else. So that's bad. A few funny results. That's Java. It goes to a negative array size exception. So thank God you cannot have buffer underflow and overflows in Java. In Haskell, I got a segmentation fault was one of the images. And that was in Golang, I think. Invalid memory address or null pointer, and many like that. So there's a lot of fun things to find in these libraries. Now, how does that relate to, how can you use that fingerprint web application? So what happens in many web applications is that you can upload an image, it gets decoded, for example, for resizing or putting a watermark or something, and then you see the result. One common thing is on website when you upload your profile picture. You upload it and then you can see it, okay? So you get to send a test and you get to see the result. And if it says an error, it's also a result. Say, oh, your image is not valid, that's also a result. See, for example, on Amazon. So what you can do is you go, for example, on Amazon on another site, and you will just upload all the images from my set and check all the results, okay? A funny example here, it's a photo bucket, which actually tells you it's in Perl directly in the error, like error in invalid format from resizer.pm. So you can directly here, you don't have to do too much to see it's in Perl and which libraries they use. And so, I'm going too fast, actually. Some of the results I got. Amazon uses Amazon, Shopify, Yandex, GitHub, BayIMG, and TinyPic all use ImageMagick, which is based on libping. But you can make the difference between libping and ImageMagick principally because it will also decode Ming and JNG, which libping doesn't do. Tumblr using PHP and the GD library. IMDb and LinkedIn use Java, and Pinterest uses the Python image library. So you can get some good results. And so I have made a tool in Python. It comes with a directory full of images. You upload all these images to your target. You then get all the resulting images which you put in a directory. And then you launch the Python file against this directory, and it will tell you how close it matches to any library. So for example, in my example, it says that what I tried as a 30 image match the fingerprint of Dart, 32 for Ruby, blah, 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 and in the end, 60 for PHP 5, so you can be pretty sure the website was done with PHP 5. And the code is also made so that it's pretty easy to add new fingerprints for all new images. And it's been released on GitHub, so you can grab it now. And basically, my conclusion is that even on systems that use very high-level language where you cannot really do a buffer overflow like in Java or Ruby, a lot of sites use ImageMagick that is completely written in C. So it might be interesting to start looking for 0 days in ImageMagick if you want to get into sites that have been done like that. So okay, I guess it was a bit fast. Yes, I'm done. Thank you. Questions? Any questions? Thank you, sir. Yes, sir?
Have you been able to verify your results? actually validate that Airfront does use the
Yes, for quite a few, it's actually, if you look at Stack Overflow or like that, the question is if I was able to verify that my results on this slide are correct. For some, I don't know. For some, it's pretty evident from my research that some bugs are so specific that it must be it. Like when you have three very specific bugs, I mean, the chance that it's something else is really low. And for some, if you look then on a Stack Overflow or like this, you can see questions and stuff that show that in what it's developed. So yes, for a few, I have been able to verify actually. So also, I put a few that would be also less fun if I put all stuff that is already public knowledge, you know. Any other question? Oh, yes, sir. So the question is if it works with only application that go to use this scheme and not for all web application. Well, of course, it doesn't work with applications that don't do anything about images. That's kind of normal. But even if it doesn't display the image, you get less results, but you get all the binary results about if it has accepted or rejected your image. You don't need to be able to see the result. But as long as you can upload, you get a lot more detail, a lot less detail, but as long as it tells you I accept or I refuse the image, you already have quite a few tests that work.
So for the library or the OS of the application server that runs the library?
It depends. If you can find differences.
For that, if I know just the library.
Because often the OS you can already get from the, for example, HTTP headers, but you might not really know if it's Java or Python. Like this, the web server is already giving you a lot of information, but often it will not give you if it's Java or Python or Ruby behind it, if the developer has been trying to hide it a bit. Anyone else? I guess not. Okay then. Thanks.